When we have two equations with two variables, it's almost always solvable. The only exception is down here, and we'll actually talk about this first. So this is not going to give us complementary information to solve for x or y, because this second formula is just the first formula multiplied by 2. And so these are actually both the same formula. They don't give us any extra information. But these two formulas are different. These two formulas are not simply the same thing multiplied by 2. If I multiplied the bottom one by 3, I would get 3x minus 3y is equal to 6, which looks a lot different than what we have in statement 1. But we would have 3x in each. So there's two ways to solve for two equations and two variables. One is through substitution, and the other is through elimination. So let's use elimination first. We've already got these two formulas here. Now I want to cancel out the 3's, so I'm going to leave the first formula as 3x plus 2y equals 11, but I'm going to multiply this by -1, so it would be really multiplying this by -3, which will give me -3x plus 3y, since it's multiplied by -3, equals -6. And if I add these two formulas together, the x's will cancel out. I'm going to get positive 5y equals 5. And that tells me that y is equal to 1. Now I could plug that back into either of these equations. So say we plug it in here, and we get -3x plus 3 equals -6, because the y equals 1, so this equals 3. And that gives us -3x equals, subtract 3 from both sides, -9, x equals 3. And we could have gotten the same thing by plugging it in up here. We would have gotten 3x plus 2 equals 11. That tells us 3x equals 9. And then again, x equals 3. Okay, that is using the elimination method. We eliminated the x variable by getting 0x here when we added together positive 3x and -3x. But we could also use substitution. And substitution is when you take a formula like the second formula here, and you turn it into something that looks like this. So we've actually represented one of the variables on its own equals some other information that includes the second variable. And what I can do is I can plug in this side anywhere that I have an x in my other equation, and it will eliminate some information. So in our original equation we had 3x. Well, now that will become 3 times 2 plus y. And then we had plus 2y equals 11. Now if I distribute that 3, I get 6 plus 3y plus 2y equals 11, which means 5y equals positive 5 if I subtract 6 from both sides, and y equals 1, which is what we found up here as well. And we've already shown that we can plug that in to the original equation. We could plug that in right here and solve x equals 2 plus 1, which means x is equal to 3. So either way you can solve it. Now that won't happen in this instance because we don't have complementary formulas. They're literally the same information multiplied by 2, which means that they're not going to be able to help us solve for either of the variables included within them. So that's the only thing I would look out for. If you have two formulas with two variables, it should almost always be solvable, unless you have a situation where either you get two different answers, like when you try to combine them, it just doesn't make sense. Or when you have a situation like we're seeing down here, where you have the same formula just 2 times over, either multiplied by something or actually the same formula. And in that situation, they don't add value.